Mm. Hello, we are the team number 8, conformed by Enrique Moreno and Fernando González. Here we had the scatter plot showing the sale price versus age of the cars. You can clearly see a downtrend. Older the cars tend to sell for less. Here we have the linear regression model. This means that each extra year reduces the estimate price by 38,184 pesos. Um, so we have the R squared that is 76.11%, and adjusted R squared is 75.29%. So H explains about the three quarters of the variation in price. The p-value for H is more than 0.001, so the slope is statistical significant. Residual standard deviation is 43 point 546. I don't remember that. And the conclusion of this scatter plot is that the model is clearly negative relationship, a strong statistical support, and meets model assumptions. Mm, Next, we have the results of the miles. Um, we have another regression equation that is the model for the millage. Each extra mile lowers the price by approximately 1,845 pesos. The R squared is 73.38%. Adjust is 72.46%. So millage explains about 73% of the price of variation. The p-value again is more than 0.001, so the negative relationship is highly significant. The residual standard deviation is 45,000 70 no 97, and that confirms that this is a strong model fit. We have three observations here. We have large residuals, but the diagnostic plots show no serious non-literally or heterostatistic. So, like the past model, this is a significant relationship and satisfies the relation assumptions. And in the investigation about the point 83, we had that in the categorical variable in the regression is uh, a variable that represents the categories or the groups rather than continuous numerical values. We have three types that are nominal and ordinal and binary. Nominal has categories with no order. Ordinal has categories with order, and binary have two types of categories. To use this in regression, we need to convert that into dummy variables because they need a numerical value. So we do that, and in our database, we have the binary and the no, ordinal.
Next we investigate about the adjusted coefficient of determination that is it is a correct version of the R squared that penalizes unnecessary complex in the model. So then we have here the formula, and as you can see, it depends not only on the R value, R squared value, but also on the number of predictors and the sample size. So we prefer adjusted R squared in multiple regression because it helps avoid overfitting by penalizing unnecessary variables, and it gives a more realistic view of the model performance. Also, it allows us to compare the models with different numbers of predictors more fairly. Well, here we have the multiple linear regression model with this equation that is, well, what we can see that for each additional year, the price drops by around 22,740 pesos, and for each additional 1,000 miles driven, the price drops about 900 pesos. So the multiple linear regression model is superior to the simple regression model. The answer is yes, because this model has an R squared of 0.811, which is more than any of the simple models. The adjusted R squared is 0.798, showing it's not overfitting. And also both predictors are statistically significant and the p-value is less than 0.001, which confirms the reliability of the model. Well, then we create a multiple linear regression model with including all the variables of the model that we have here the equation where x means the age of the car, y the mileage in the thousand of miles driven, C, if the car is in average condition, and W, if the car is in excellent conditions, and for B is if the car had only one previous owner. Um, what we what this tells us about is well, being in excellent conditions add 65,630 pesos to the car's value. That it's a big impact. And average condition adds a smaller amount, while having only one previous owner actually decreases the price slightly, but it's not statistically significant. So the next, please. The R squared now increased to 0.896 and the adjusted R squared to 0.876. This means that the model explains almost 90% of the price variation. So overall, this full model performs better than the previous one, thanks to the inclusion of the relevant categorical variables like the excellent condition variable. Well, when then we obtain the best subsets options with Minitab regression option that help us to identify which combination of variables best predicts of the selling price. We focus on only three main metrics: R squared adjusted, that that's the higher the better, R squared predicted, that is how well the model generalizes, and CP of Mallows, that is the lower the better. With this, we can see that the best performing models are age, mileage, and excellent condition. Um, with all these results, our final conclusion is that the optimal model includes age, mileage, and excellent conditions as predictors. These models balances simplicity and predictive power and is strongly supported by the best subset analysis.